Well, let's look at this first example with implicit differentiation. Given 4x squared minus 9y squared equal 36, find the derivative of y with respect to x. So let's remember the steps that we go through. Step one is that we take the derivative of both sides, don't we? Yeah. Kind of take derivative of both sides. Okay, so that is with respect to x in this case. I didn't say that, but with respect to x. So we have the derivative of the left side, which is 4x minus 9y squared, and that's got to be equal to the derivative of the right side, which is just 36, the derivative of 36. And as we saw previously, when we take the derivative of the left side, that's a derivative of the difference. So that's the difference of derivatives. So that ends up being the derivative, the derivative of, derivative of 4x squared minus the derivative of 9y squared, both with respect to x. And of course the derivative of the constant 36 is just 0 again. Now, once again, we get back over here to the left side, and the very first derivative is the derivative of 4x squared, and it's with respect to x, and so that's a normal derivative. That's just 8x. But then on the next derivative, we're taking the derivative of things about y with respect to x, and that's when this implicit differentiation, or this chain rule idea, has to come into play. Pardon me, let me clear my throat. Sorry there. So what we're really doing is thinking of y as parentheses. And so what we would do is we would multiply the exponent that's on the parentheses 2 with the 9 and get 18. And then we would decrease the exponent on the parentheses by 1. And so we won't put an exponent of 1. We just have the y. But remember, y is parentheses. And so we have to use the general power rule, so then we have to actually take the derivative of what's inside the parentheses. See, that's the derivative of y with respect to x. We saw that previously. Okay, well, once we've taken the derivative of both sides, and of course the issue, this is always going to be the big issue, is how we go from things that look like this to how we got below. So make sure you understand that process. Okay, well then step 2 is simply to solve now for the dy dx. See, that's all we're going to do next. And so to solve that equation that we have above for dy dx, we need to subtract the 8x on both sides. So we'll end up with negative 18y dy over dx is equal to negative 8x when we subtract 8x from both sides. And then lastly, we need to divide out the negative 18y, don't we? When we divide on the left side by negative 18y, we're going to be left with dy over dx. And then when we divide on the right side by negative 18y, we'll have this expression, which can be simplified, can it? So let's see. Negative over negative is positive, and let's see what 2 will go into 8 4 times, into 18 9 times. So doesn't this become 4x over 9y? Now, this is something that's also new. Note, when we're doing implicit differentiation, implicit differentiation, the derivative may have more than one variable in it. Well, I've bungled up differentiation there. I'm sorry about that. The derivative and the derivative we're talking about here is dy over dx may have x and y values. Just as we do here, 4x over 9y, and that's something brand new to us, isn't it? Well, this kind of gives us an idea of how we're going to approach the problem that we're going to do next here. In this case, the problem, okay, I guess this is really example 2, isn't it? Let me write it out here. Find, I tell you what, let me save some time. Let me pause and I'll write it out and then we'll come back to it. Okay, here we are. We're to find the slope of the tangent line to the circle x squared plus y squared equal 25 at the point 3, 4. Now, we don't really need any geometry here to do this problem, but let me remind you that the equation of a circle is normally of the form x minus h, the quantity squared, plus y minus k, the quantity squared. You saw this in college algebra, didn't you? Is equal to r squared, where h comma k is the center of the circle, and r is the radius. And so I'm just trying to tell you what we're doing here. Again, we don't need to have this information to complete this problem. But what we have is the x squared plus y squared. Well, what are we subtracting from x and what are we subtracting from y? That is, what is our h and what is our k? They're both 0, aren't they? So for this circle, the center is the origin. The center is 0, 0. And what is the r value? That is, what are we squaring to get 25? Okay, the radius in this case is 5. So if we were looking at this circle, let's just kind of sketch one in here. We've got a circle that is centered at the origin and has a radius of 5. So let's just kind of sketch one in here. So that means this is where 5 is, right? And this would be 5 because the radius is 5. Now, what we're doing is we're looking for the slope of the tangent line at the point 3, 4. And 3, 4 would probably be about right here, wouldn't it? It would be roughly where the point 3, 4 is. And so, and then of course the tangent line to that point would be like this. So what we're wanting to know is the slope of that tangent line. And obviously from our little diagram, we're expecting it to be negative, aren't we? Okay, well let's get to this. That we first understand we're going to have to use implicit differentiation, and that's what we're talking about here. Implicit derivative is what we're going to have to find. See, when we find slopes of tangent lines, we need derivatives, don't we? And so we're after the derivative of y with respect to x. That's what we're looking for, is the slope. Okay. Now, in the example just previous to this, remember when we're doing implicit differentiation, we may get the derivative that has a y and an x in it. I mean, certainly it's not unusual to have x's in it, but this is the first time we've seen y's as well. So let me point out to you that when we evaluate this derivative, we may need the x value and the y value of the point, where previously we've only used the x value. So, and that's the reason I've written it in this fashion. That straight vertical line means evaluate it at, and here we're going to evaluate it at the point 3, 4. So, we need now to calculate the derivative of y with respect to x, and we're going to have to do it implicitly. Okay, so we take our equation, x squared plus y squared equal 25, and we find the derivative of both sides. This is beginning to be routine now, isn't it? Okay, so now what do? We think, oh, on the left side we have a sum, so we're going to take the sum of the derivatives. We're taking the derivative of each term there, aren't we? And of course on the right side, of course, we get 0 when we take the derivative of the constant. Now, derivative of x squared with respect to x, since the variables match, that's a normal derivative, that's 2x. But the derivative of y squared with respect to x requires this implicit differentiation. And that is, we're thinking of y as stuff about x, but we just don't know what, so we're thinking of y as parentheses. And so we take the 2 in front of the parentheses and then decrease the power on the parentheses. Remember, y is representing the stuff inside the parentheses. And then we have to multiply what's the derivative of what's inside the parentheses, and that's the dy dx. Okay, now we need to solve for the derivative, because that's what we're asked to find, isn't it? Okay, so what we'll do is we'll subtract 2x on both sides. Come over here. That's a dy on top. Subtract 2x on both sides, so we get this. Now divide both sides by y. And we'll then have dy dx, except we can simplify further, can't we? So the derivative of y with respect to x is simply what? Negative x over y. Well, for our slope, remember, for our slope we need to evaluate that derivative at the point 3, 4. So let me rewrite it in here. The derivative of y with respect to x evaluated at 3, 4, which just means we have to use the x value of 3 and the y value of 4. So we put remember it's a negative, and our x value is 3, and our y value on bottom is 4, so we get negative 3/4, which certainly is feasible with the little diagram that we showed. So there's the answer to this question. There's the slope of the tangent line at 3, 4. And before we move to the next problem, I want to just give a little preview here, not preview, but a little more information to show you that we could have done this a little differently. And here's what I mean, is that if we looked at this x squared plus y squared, and I'm not proposing we do this, I just want you to be a little more informed. We could have solved this for y by subtracting x squared on both sides. And then when we solve for y, we'd have to say, since y squared is that, we'd have to say y is plus or minus the square root of 25 minus x squared. Okay? Now, here's what I want you to recognize, that we have y is equal to positive 25 square root of 25 minus x squared. That's the plus part. And then we also have y is equal to negative square root of 25 minus x squared. And I want to refer back up here to the original graph. See, the original graph is that of a circle. Now, the top half of that circle is where y is bigger than 0 or equal to 0, isn't it? Because the y values are in the above the x-axis. And so what we see here for y equal, the equation y equals square root of 25 minus x squared is actually the top half of that circle. And on the other hand, if our y's are negative, that would be the y values that are below the x-axis. So this is the graph for the y's that are below the x-axis. Now what we could do then, under these circumstances, we could find the derivative of y being positive square root of 25 minus x squared in an explicit way. See, we can do that explicitly. we could find the derivative of y with respect to x here, and we would have to remember that that square root is like a power of 1/2. So we'd have to bring that 1/2 down and decrease the power by 1, so we'd get a negative 1/2, and then multiply with the derivative on the inside, which would be a negative 2x. And when we simplified all that, we would end up with negative 2 times 1/2 is a negative 1, so we'd have a negative x in the numerator, and a square root of 25 minus x squared in the denominator, and then we could calculate the slope of the tangent line that we're referring to here, and we could have done it explicitly. You can see that this is, of course, a little more complicated. We would have done a lot of things to figure out how to get here. And by the way, if we would have used this equation, let's come over here and put our value of what? X value of 3 in, we would have had a negative 3 on top, okay? And then remember, x is 3, so we'd have a 25 minus x squared, or 3 squared, which is 9 on the bottom, square root of that. And of course, 25 minus 9 is 16, and square root of 16 is 4. And look at that, we get the same result. Now, we're practicing implicit differentiation, and this is the method we would have used on this problem. And there are some problems where you have no choice but to do this, that as much as we'd like, we can't ever solve for y. We were kind of fortunate here, but it required a lot of extra knowledge. Okay, well, this is the end of example 1 and example 2. We'll start up and look at some other examples that require a little more information or a little more work.